This is Mandana Tejasri, Department of Electronic Communication Engineering from Thalla Padmavati College of Engineering, Warangal, Telangana. I would like to thank Emertxe Information Technology Private Limited for giving us the opportunity of embedded system internship and making project on washing machine simulation using FixSimLab. The next slide is topics covered in the internship. First one is introduction to embedded system. Next, basics of embedded system. Introduction to microcontroller and microprocessor. Block diagram. Project requirements. Project demo. Conclusion. These topics are covered in the internships. And the next slide is introduction to embedded system. An embedded system is a combination of hardware and software designed to perform a specific task. Embedded systems are specialized computer systems designed to perform dedicated functions or tasks within the larger electronic or mechanical systems. Unlike general purpose computers, embedded systems are designed to perform one dedicated function, making them highly efficient for the task. Commonly, common programming languages used are C++, and assembly languages. Embedded systems are widely used due to their reliability, efficiency, and ability to operate with the limited resources, making them essential in industrial, commercial, and consumer applications. And the next slide is types of embedded system. Embedded systems are divided into two types. First one is based on performance and functional requirements. Second one is based on complexity. In first one, it is again divided into four types. That is real-time embedded system, standalone embedded system, network embedded system, mobile embedded system. The second one, based on complexity, the embedded systems are divided into three types. First one is small scale embedded system, second one medium scale embedded system, third large scale embedded system. Next slide is basics of embedded C. Embedded C is a extension of the C programming language designed specifically for programming embedded systems like microcontrollers, sensors, and other hardware that operate in real time and resources constrained environments. Extension on standard C language for embedded systems, and it is used to program microcontrollers and embedded hardware. The basics of the embedded C is supports hardware timers and interrupt compatible with the various controller architectures. Then next slide is data types in C. The data types are divided into three types: primary data types, user defined data types, and derived data types. And the primary data types are divided into four types. First one is character. Again, the character is used to store characters. It can be signed character or unsigned character. In int used to store integer variants. These include int long int, unsigned long int, long int, unsigned long int, short int, unsigned short int. Float, it is used for single precision floating point numbers, and it is divided into three types: float, double, long double. And then last type in primary data types, void. It is represents the absence of any data type. To the user defined data types, it is divided into two types: enum and type def. Enum is used for enumerating named integer constants, and derived Then coming to the derived data types, in it is divided into four types: pointers, arrays, structures, and unions. Pointers hold memory addresses. Arrays store multiple elements of this same type. Structures are used to group different data types. Unions are similar to the structures but with a shared memory for members. The next slide is conditional statements in C. Conditional statements are used to make decisions in C programs. They, they allow the program to execute certain blocks of code based on whether a condition is true or false. First one is if statement. The if statement checks a condition. If it is true, the block of code inside it executes. And this is the code for the if statement. And the second one is if else statement. The if else statements provides an alternative block if the condition is false. This is the syntax for the if else statement. And third one is if else if statement. This is used to check multiple conditions one of the other. And next nested if. In nested if, one if statement is inside another. It is used for checking multiple levels of conditions. Next one is switch case. Switch statement is used when there are multiple possible values for a variables or expressions. It works as an alternative to the if else if statement. This is the syntax for the switch statement. Next, coming to the operators in C. The first operator is unary operators. Unary operators operates on a single operand. The common unary operators are increment, decrement. These are used to increase or decrease the value of the variable by 1. Second one is binary operators. Binary operators require two operands and are further divided into arithmetic operators, relational operators, logical operator, bitwise operator, and the arithmetic operators used to perform basic mathematical operations like addition, subtractions, multiplications, divisions, and modulus. Relational operators are used to compare two values written on a Boolean result based on the conditions. Logical operators used to perform logical operations, often used in conditions and decision making. Then bitwise operators operates at a bit level used to manipulate individual bits of the data. Third one is assignment operator used to assign values to the variables, also includes compound assignments which combine assignment with arithmetics. Last one is ternary or conditional operators. This is the only operator in C that takes three operands. It is used as a shortcut for if-else statement. It returns expressions 1 if the condition is true, otherwise expressions 2. And the next slide is array and pointers. An array is a collection of elements of the same data type stored in the continuous memory location. It allows storing multiple values under a single variable name, providing an efficient way to manage and access related data. Pointers. Pointer is a variable that stores the memory address of another variable. Instead of holding a direct value, a pointer holds the location in memory where a value is stored. This allows for direct manipulation of data in memory and enables powerful features like dynamic memory allocation and efficient array handling. And the next slide is introduction to microcontroller and microprocessor. Microcontroller is a compact integrated circuit designed to perform a specific control tasks. It contains a CPU as a processor, memory like RAM and ROM, and input output ports on a single chip. It acts as a mini computer used in embedded systems to control machines or processors. Example for the microcontrollers are PIC16F877A used in PiximLab 8051 Intel. Next, coming to microprocessor. A microprocessor is an integrated circuit that contains only the CPU of a computer system. It performs arithmetic logic and control operations based on instructions from the memory. Example for the microprocessors are Intel 8085 8-bit, Intel 8086 16-bit, Intel Core i5 or i7 Ryzen series. And coming back to block diagram. In this block diagram consisting of microcontroller, switch 5, switch 6, switch 4, switch 1, display, buzzer, motor. Switch 5 is used to power on the screen. Switch 6 is used to stop or pause the program, and switch 4 is used for navigation. It is nothing but scrolling the screen. And switch 1 is used for door status, when whether the door is opened or closed. And display, LCD used as displaying the washing status, and buzzer is up used, and motor, and also motor is also used. Next slide is project requirements. Software tools are MPLAB XIDE. MPLAB XIDE is an integrated development environment developed by Microchip Technology for programming and debugging the range of microcontrollers, including PIC, DSPIC, AVR, and SAM devices. It provides a user-friendly interface that allows developers to write, compile, and debug embedded C code using compilers like XC8, XC16, and XC32. Built on the NetBeans platform, MPLAB XIDE supports advanced features like real-time debugging, project management, code completion, and integration with the tools such as PicKit, ICD, and MPLAB Snap. It also works seamlessly with the MPLAB code configurator, allowing graphical configuration of peripherals and code generations. Available for Windows, Mac OS, and Linux. MPLAB XID is a powerful and flexible tool for embedded system development. Next software tool is XC8 compiler. It is a C compiler from Microchip for 8-bit PICs. Both programs runs on Windows and Linux. And the last software tool we used is PiximLab. PiximLab means Programmable IC Simulator Laboratory. PiximLab is a real-time emulate of development boards with integrated MPLAB X debugger. PiximLab is a graphical real-time simulator used for simulating microcontroller based on embedded system, especially with Pixim microcontroller like PIC16F877A. And the next slide is PiximLab architecture. It contains 40 pins and it has the 5 ports. The ports are port A, port B, port C, port D, port E. It is a 8-bit architecture. Every port has the TRIS register. TRIS is nothing but tri-state register. In this tri-state register, tri is nothing but logic high, logic low, high impedance. It contains 16 LEDs, 8 LEDs in port D, and 8 LEDs in port B. Port A consists of 6 pins, that is RA0 to RA5. Port B consists of 8 pins, RB0 to RB7. Port C consists 8 pins, RC0 to RC7. Port D consists 8 pins, RT0 to RD7. Port E consists 3 pins, RE0 to RE2. The hardware peripherals used or components used in this project are tactile switch. In microcontrol, switches are oftenly used as input to control the operation of the device or to interact with the user. When the button is pressed, the switch turns on, and when button is released, the switch turns off. An array of tactile switches from the digital keypads. Here, RB3 is used as a switch for navigation or scrolling between the options, and the RB4 is used as switch for powering powering on the washing machine and resume, and RB5 is used as the switch 6 stop and pause the ongoing program, and RB0 is used as the switch to indicate the door status of the washing machine. Then timers. The next component is timers. Timers is nothing but simple a binary counter that can be configured to count the clock pulses. Once it reaches the max value, it will roll back to the zero, setting up an overflow flag and generate the interrupt if enabled. The PIC 16F877A has the three independent timers which can be used as timer counters or for pulse width modulation generation. They are timer 0, it is 8-bit timer, and the timer 1 is 16-bit timer, timer 2 is 8-bit timer. Interrupts. An interrupt is a communication process which causes the processor to stop its current task and handle interrupt sources. The sources are divided into two types, external source and internal source. Interrupt service routine ISR is a software routine that hardware invokes in response to an interrupt. ISR examines an interrupt and determines how to handle it, execute it, and returns to a logical interrupt value. The PIC has only interrupt service routine. Buzzer. The buzzer in washing machine is used to keep in track of washing cycle. It activates for 2 seconds when the washing is completed successfully. And it, and next coming to the fan. Fan in the project is used to represent the working of washing machine. The spin of the motor starts when any washing mode is selected and continues till the end of the washing cycle. The motor stops when it detects door is opened and start again when door is closed. CLCD or matrix liquid crystal display can interface with the 4 or 8-bit microprocessor. It is an alphanumeric LCD display module, meaning it can be display alphabets and numbers. It consists of 4 rows and each row can print 16 characters. It can work on both the 8-bit and 4-bit mode. The CLCD in washing machine is used for displaying the current status of the machine. Now I'm opening the MATLAB X IDE software. In this, we can write the project code. The project name is washing machine. It consists of the header files, important files, linker files, source files, libraries, loadables. The header file consisting of the required files for this project, and the source file consisting of the required files for this project. In the source files and header files, we can write the code. After completion of writing code, we have to save. Here is the save option. After saving this code, we have to build for main function. To build main function, click on this. Here there is a arrow mark. So we should click on arrow mark. Then we have to select build, click main function. After clicking this, we will get warnings are built successful. So here I get the built successful. The project code was run successfully. Then we will see the output at PiximLab. Now I will open the PiximLab. I'm opening the PiximLab where we can see the output. After opening, we have to select the board. The board here I'm selecting is PickGenius board. Then we have to select microcontroller. In this microcontroller, we have to select PIC16F877A microcontroller. Then we have to adjust the clock frequency to 20 megahertz. In this PiximLab board, there is a LCD. It is in two modes. One is 16 cross 2 and one other one is 16 cross 4. And it is the fan and it is buzzer. It can be adjusted by these. These are the switches. RB0, RB1, RB2, RB3, 4, 5, 6. It is considered as a switch 1, RB0, RB1 considered as a switch 2, RB2 considered as a switch 3, RB3 considered as a switch 4, RB4 considered as a switch 5, RB5 considered as a switch 6. These are the keypad and these are the LEDs of port D and these are the LEDs of the port B. Now to see the output here, we have to select the file. Load the file. So we have to select the project file. Here is the project file. I have selected, then open the file. It displays, press key 5 to power on washing machine. Now I'm pressing the switch 5 to power on the washing machine. Displays the power on washing machine. Then after washing programs, it displays consisting of 11 types of washing programs. To scroll down the screen, I'm using this with switch 4. See, I'm pressing the switch 4. Daily, heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua wash. Now I'm selecting the heavy. To select the heavy, we have to press long click on switch 4. Then it displays the water level. Water levels are 5 types: auto, low, medium, high, max. I'm selecting the auto level. Then I'm pressing the long click on switch 4. Then it displays the press switch. Switch 5 considered as a start, switch 6 considered as a stop. Now I'm starting the program. Then I'm pressing switch 5. Now it displays function, wash, timer will be on. These are the seconds. And switch 5 for start and switch 6 for pause. Now I'm pressing switch 6. It pauses. See here, I'm pressing switch 6. Then the fan will be rotating off and the program will be off condition. To start or to resume this program, have to press switch 5 to start it again. Now I'm pressing switch 5. It will be in on mode. If I press switch 1, the door is opened. Please close the door. When I resume the switch 1, it continues the process. Here I will say it again. When we press the switch 6, it paused the program. To resume or to continue the program, we have to press switch 5. Resume. The working condition will be in continue mode. If I press switch 1 continuously, the door is opened. It displays the closed door. See here, I'm pressing switch 1. It displays door is opened. Please close the door. When I leave the press switch 1, it displays. After completion of this, it displays program completed. Remove the cloths. The fan conclusion. To conclude, the washing machine simulator project effectively met its objective of building an interactive and user-friendly system for operating a washing machine using the PIC16F877A microcontroller. The system enables user to choose different washing modes and water levels, while the display provides real-time updates on the current operations and remaining duration. This project highlights the roles of embedded system in enhancing the usability of household appliances and emphasizes the adapt adaptability and usefulness of microcontroller based solutions in practical real world applications. And thank you again. I would like to thank the Emertxe Information Technology Private Limited for giving us the opportunity of embedded internship and making project on washing machine simulation using PixSimLab.